Okay, in this video I'm going to make a few suggestions on how you can make an improved steady hand game. So let's just have a quick look at what a steady hand game, a normal steady hand game might look like. So typically has some sort of difficult to navigate track, maybe it's put in a box or on a base plate or something like that. And then typically you've got some sort of wand or holder or something which has then got a hook, and hopefully you're all familiar with this. You hold on to that handle and then you try to get the hook all the way along. But actually it's alright as a game, but of course there's no confirmation that you are able to get like from one end fully to the other than just actually having the fun of doing it yourself. Now some people improve this steady hand game. Obviously they can have lights and buzzers and things, but you know, if for example the LED only illuminates when the track is touched and then it goes off immediately if it's not touched, that gets a little bit not so good. So maybe you would have it latching, so it would, maybe the LED would stay on until the device was turned off, so let's just have like a on-off switch here. And maybe we'll have like I don't know, an LED or whatever, and then possibly some sort of buzzer. So we could perhaps have the LED come on for like 5 seconds if the track was touched, and then the buzzer come on for 1 second or something like that. So you're going to have a latching circuit. But you know, how would that actually be done? Well, one way is with a microcontroller. So let's just quickly consider a circuit with a microcontroller. Now this isn't a Genie microcontroller if you're one of my students. This is just like a generic microcontroller. So I just have two outputs, Q0 and Q1 are just going to be my names of my outputs. So maybe Q1 will be an LED. So that goes, the current is going to be sourced from the output, go through the current limiting resistor, go through the LED, and then maybe we'll have a buzzer as well. Like so. Okay, so that will be my my sounder there. So touching the track is very, very simple actually. Touching the track is going to be implemented just in the circuit anyway as a switch. So if that's maybe my positive supply and that's my 0 volts down there, then effectively touching, because it's momentary, touching the this hook to the track is just a momentary thing. It would just be implemented like this, and then so obviously we don't actually have a physical switch, so that physical switch wouldn't actually exist. So all we need to do is just have we can actually get rid of that. So then just one side of this that would be connected to the track, say, and then this would be connected to the wand, and then of course when then the wand touches the track, then effectively you've connected that. Okay, now the question is, how could we make this better? And my suggestion would be, it would make it much nicer if when you manage to get the wand all the way along the track, there's some sort of game over, win, something like that. Not game over, win, that would probably be a better way of expressing it. So how can we do that? Well, just like touching the track was effectively like a switch because it's digital I/O, it's either you touch it or you haven't touched it. Getting to the end is digital I/O, you touched it or not touched it. So we can do that as a switch. So let's draw a possible circuit for that. Once again, we're still going to use a microcontroller. I won't bother doing the outputs in this one. The inputs, let's have two digital inputs. By the way, this one had one digital input, so let's just call that D0. This time I'm going to have two digital inputs, D0 and D1. You can call them any name you want, of course, makes no difference. And so we'll have the supply voltage, 5 volts, 0 volts here. And just like before, I'm going to have pull-up resistors, and I'll have these switches here, and then I'll have another pull-up resistor, and I'll have a switch here. By the way, I don't know why I drew the switches so low down, but anyway, I did, so it makes no difference really. Right. Okay, so let's call this switch then, let's say call that one win, let's be positive, and then this one lose. So if you touch the track, you lose. If you get to the end of the track, you win. Okay? Now, how could we actually do that? Well, honestly, it's much easier than you probably think. So, now bearing in mind you can't win and lose at the same time, it's going to be quite easy. So let's draw our little box, our steady hand game again. Have a nice track like that, but this time with the track, what I'm going to do, and this is just a flexible metal track, remember, that we could mould to whatever. And now all of this is going to be a conductor of electricity, but then what I would propose is around the final piece, so if this is the start and this is the end, around the final piece of conductive track, what I would do, I would put maybe something like a bit of heat shrink on there, which would be an insulator. And then around that insulator, then on the outside of it, then wind something which is a conductor. Okay, now that could be something like copper foil, it could be tightly wound copper wire or anything like that, but it's very, very important that that wire doesn't come into contact with the track, and you'll see why in a bit. Now, so then we have our wand just like we did before, and it's got the hook just like it had before as well. Now, the wand can be connected to either of these because actually they are the same thing, they're at the same potential, so it makes no difference. In fact, you could even have your wand connected down to here because it's still the same 0 volts. Okay, so what I'm going to do, I'm just going to connect it to here. Okay, so effectively now that is there. Now, if I then touch the hook to the touch it to the track, say, so if I touch it to the track, then I want to lose, don't I? So this side of, remember, this isn't actually going to be a real world switch. This is just switch is just simulating the fact that it's a momentary contact either to the track or to this end position. And then so what I'm going to do then, I'm going to connect that to the track. Okay, so hopefully you can see that if I then touch the hook to anywhere on the track, then I will immediately lose, which is what you're expecting. Now the clever bit, I suppose vaguely clever bit anyway, is that then we also have this, and we connect that to there. So if I now touch this to the this end part here, which is just a piece of uninsulated wire just around there, or copper foil or whatever, then that's going to complete the circuit between 0 volts, because remember that's all same 0 volts, 0 volts and the win. Okay, which will make D0 go logic low. Now, just in fact, I should just mention that. So imagine when these switches are open, there's no flow of current through this resistor, therefore there'd be no voltage drop across the resistor, so that would actually be at 5 volts, and that would be at 5 volts. But as soon as you complete this circuit by pressing the switch or completing the circuit here, then you'll actually have the flow of current. With the flow of current, you will have a voltage drop because V equals IR, and you'll actually drop the full 5 volts. On this side it would be 5 volts, and this side it would be 0 volts. So when you touch these two connections together, however it is you're doing it, then these will go to 0 volts or 0 volts. So that's the way that I would do it. Now you might notice that we actually don't really need to use both of these points, we only need one of them. So, you know, you could, if you were doing this, you don't have to. I mean, I think it's quite nice to see the win and the lose as separate switches, but there would be nothing stopping you from, say, doing it like this. And so let's have those pull-ups. And those are my digital inputs, so whatever D0 and D1. And then what I could do, I could, if I wanted, have it like that, couldn't I? So then that could go to the wand, the hook, whatever. Okay, so that's my hook at 0 volts potential, and then so then if I touch the hook either to what are we going to call this one, win, and that one call it lose. So if the hook touches win, then D0 will go to logic 0, because that's what the hook is at, potential 0. Or if we were to touch that to lose, then it would then take D1 to logic 0. Okay. And as you can see, I've just quickly redrawn this circuit. I've put the two outputs, a buzzer and an LED, and I've added a little bit of annotation here. I've also noted down the voltages. Remember, if you connect the track up on this side, then you've got the track at 5 volts potential above ground, and also the touch to win, that bit there, that is also connected at 5 volts potential. And then the wand is at 0 volts potential. So if you touch that to the track, then you are basically joining those two connections together. And if you touch the wand to the to this end bit, which is around here, then effectively you're just joining those together as well. Just bear in mind that it doesn't make any difference at all whether you connect your track to this point here or that point there, because look, it's all at 0 volts potential. Okay, hopefully that is useful for people. By the way, actually, if I were going to do this, if I were a student and I fancied it, I might even include some, just like I've got a win here, I might even wrap around here and have a start as well. So then I would just need 3 inputs. Does that make sense? And if it does, great, and maybe that would be a nice little project for someone. I'm not going to post that circuit schematic exactly, because I think you need to have a little think about that, but it'd be really easy to have a start, lose and end as well. Okay, all right, that's it.